All right, you are getting set to take the matter quiz. It's the first quiz in the second semester, so let's get to it. If you want to understand if something is matter or not, we're going to start right here, and we're going to ask two questions. If something that you're thinking about passes two tests, then it is indeed matter. So the two questions are, does it have mass and does it have volume? If it has those two things, then it is indeed matter. And if it fails either one of those tests, then it is not matter. So let me write a little bit in these spaces here, and I'll be right back. So one test, the mass test, if something is attracted by gravity, then it has mass. All right, and the other test, if something has volume, then it takes up space. Usually students are pretty readily able to understand volume if it takes up space. But sometimes they struggle a little bit more with does it have mass or not. Specifically, they have trouble with the mass question when we're talking about air. They understand that you can use air to fill up a football or a basketball or something, so they understand it passes the volume test. But the mass test, can you take air and put it on a scale? Well, the trouble is you've lived your whole life with air all around you. But think about this. If here is the Earth has this very thin layer of atmosphere all around it. If you could take gravity and suddenly switch it off, if gravity were to disappear, the motion of these air particles, they'd just bounce out into space and be gone forever. So yeah, air is attracted by gravity. Matter of fact, something else you probably haven't thought of, just like stepping into a pond, you feel lighter in the water because the water's helping hold you up. In the atmosphere, that's helping hold us up a little bit. So if I were to get rid of some of these air particles, if I were standing on this scale right here, without the air helping hold me up, then the scale would actually read a higher number if you took away the atmosphere. So that's just more proof that the air does have mass. Now, every so often, a kid will say, well, what about light? Is light matter? Well, light doesn't have any volume, so it fails that test. You can't fill up a football with light. You can shine a light into a grocery bag, but you can't catch light in the grocery bag. So it fails the volume test. But some kids argue that light has mass because light is affected by gravity. Every so often a kid will be aware that light from some distant star can come by our sun. It can actually be bent by the gravity of our sun. That's true, and even if you allow for that stuff, it still flunks the volume test. So light is not matter, and air is matter. So we're going to put matter in this box right here. So if you pass those two tests, you move on and you're matter. So there's two categories of matter. They are pure substances, and they are mixtures. So let's start over here on the pure substances side. Anything that is a pure substance has a formula. Two categories of pure substances. One of them is elements, and the other one is compounds. So the formula, or for an element we call it a symbol, the symbol of an element, one of them would be gold. It's Au. Or oxygen is just O. Or hydrogen is H. There's lots of elements. There's in the neighborhood of 100 kinds, actually less than 100 found on the planet. And each element has its own symbol. Compounds, they happen if you take these elements and you chemically bond them to other elements. For example, if you take hydrogen and bond it with oxygen, you get the compound H2O, or water. What would that look like? That would look like one oxygen atom and two hydrogen atoms connected to it. And that connection, that is a bond. If you have atoms that are bonded to each other and they're different types of atoms, you have a compound. Can you go back and forth between elements and compounds? Yes, you can. It takes a chemical process. Sometimes they're pretty simple, sometimes they're more complex. An example of a chemical process might just be adding heat. If you add heat to certain compounds, you can separate them into elements. Sometimes electricity. If you run electricity through water, you can separate it into its elements. Or reacting things with acid. These are different examples of chemical processes, and you can go back and forth between elements and compounds. So let's jump over to the mixture side here. What are the two categories of mixtures? One category is called homogeneous, and the other one is called heterogeneous. If something is homogeneous, then that means it is the same all over. If something is heterogeneous, that means it's not the same all over. Typically, not always, but typically, when chemistry people are talking about mixtures like this, homogeneous and heterogeneous, typically they're talking about its appearance. So if you look at the air in this room, it looks the same all over, so you would say that it is homogeneous. But if you're not talking about appearances, maybe you're talking about smell or odor. If you walk by someone who's wearing perfume or cologne, you might smell cologne in one part of the room but not in another. So in that case, the air could be said to be heterogeneous. It's not the same all over. So I'm putting it in both places here just to give you a heads up that if you are asked a quiz question, you might have to think a little bit about homogeneous or heterogeneous. And just like in elements and compounds, we use a chemical process to separate them or to go back and forth. With a mixture, we can go back and forth. We can separate them with a physical process. What's a physical process? A physical process is one where we don't mess with the bonds. So as an example, let's say you've got a salad and you want to separate the parts. Well, all you have to do is grab the piece of lettuce, take it over here, grab a piece of tomato, take it over there. You're just using a physical process. You're just reaching in and grabbing something and separating it. You're not messing with how the atoms are actually bonded to each other. Another example of a physical process would be using boiling point to separate something. If you have a mixture of alcohol and water, all you have to do is heat them up and the alcohol boils out before the water does. You're not changing the bonds. You still got alcohol and water, but you used a physical process to separate the two. So there is my video on the matter quiz, and good luck.